All right, this video is looking at the stages of sleep. Now, when you are pulling up this video, will you please pull up in another window? I want you to pull up on Canvas. So pull up Canvas. And then go on under module 7 through 10, and it says Conscious of the Two-Track Mind. And the fourth thing down, it says Stages of Sleep Simulation. Click on that. That's a quiz that goes along with this video. So pull that up now. So pause the video right now, pull it up, and then play the video. Okay? So pause. All right, now I am going off the assumption that you've already found it. So I'm going through and talking about stages of sleep. So this kind of simulation here, it actually is a simulation that is online. The problem with it is that it uses Flash Player, and your iPads don't have Flash Player. So I actually showed this in class. If you were not here, this is your review of what we did in class. So first of all, sleep. Did you know that we actually sleep 1/3 of our life away? The study of sleep is actually very relevant because it's a 1/3 of our life, and we need to know what's going on there. So first thing that I have to show you is that this beginning part of this simulation was talking about what an EEG is, electroencephalogram. I can't say it. It's an EEG. So this is looking at where EEGs used to be placed, like the electrodes. Look, oh my gosh, how many there are. I wouldn't be able to sleep like that. Okay, but this is what I wanted to show you. This is the Eeg tracing. It says the electrical signal from each electrode after processing and amplification drives a pen that traces a path on a continuously moving roll of paper. The paper, which moves at a constant speed, has evenly spaced markings so that this activity recorded on the tracing can be matched to the other observations of the sleeping person's behavior. So in addition to this paper EEG record, most researchers also have the EEG information in computer format. The continuous electrical signal from each electrode is sampled once per second and stored in digital form for later statistical analysis. So I wanted to show you, this is how they get EEG readings. So they place electrodes on your head. They look at when you are awake and when you're asleep and what your brain waves look like. Okay? So this is what I wanted to get to. This is talking about states of alertness. So I'm not going to read you the whole thing. You can read. Obviously, I'll read some slides and some that I won't. I'll summarize. Okay, there are a couple of things I wanted to point out to you. Okay, so they're going to be placing the electrode on the occipital part of your brain. So that's the back of your brain. And what they found was that there's a difference between your brain waves when you are awake but relaxed and when you're awake and you are alert. Okay, so when it says when the person was awake and relaxed, so if you are awake but you have your eyes closed, the waves are more smooth and regular, so you're relaxed. Your brain waves is kind of like slow breathing. Okay, so they have about 10 peaks per second. You can see on here that these are our alpha waves. It's called our alpha waves. That's the first Greek letter of the alphabet. Okay, so our alpha waves happen when we are awake but we are relaxed. Okay, but when a person opens his or her eyes and they're focused on something, okay, so they're awake and alert, then our brain waves become faster. And these are called beta waves. They're faster and they're more irregular. Okay, so that's because it's the beta is the second letter of the alphabet. So you can see that they're faster, more alert. Okay, so that's alpha waves, beta waves. So when researchers examined the EEG tracings for a single electrode across an entire night's sleep, they found a similar pattern. Slower waves were associated with greater relaxation. Brain activity gradually slowed as a person drifted off to sleep, then got steadily slower and more irregular as the person moved into deeper and deeper sleep. So look at our EEG tracing. So here, this is when you're just drowsy and you're, barely conscious and you have the head bob going on. Okay, this is your brain activity. You have a high frequency, so you have lots of spikes. Okay, very low amplitude. They don't go very high. As you continue to fall off to sleep, okay, you'll notice that our frequency becomes less frequent. Okay, they're a little more spaced out, and our amplitude is a little higher, not much, but a little higher. And then when we get to the deep sleep, okay, we have very high, low frequency. They're very spread out. You're very relaxed. It's very slow, but our amplitude is much higher. So our amplitude actually goes a lot higher when we're in a deep sleep. Okay, so looking at the stages of sleep. So stage 1 is that transition from wakefulness to sleep. So this is going to be when you're first falling asleep. This is when you're going to see those slight hallucinations. So if you've ever had this happen where you're falling asleep and then you kind of like jerk awake, maybe because you have this hallucination that it happens to me where I'm walking down the sidewalk and all of a sudden, whoop, hit a patch of ice. I'm always hitting patches of ice when I go to sleep. And all of a sudden, whoo, I tripped or I fell and I jerk awake. Okay, that's what happens in stage 1. And in stage 1, you can see the EEG readings. They were high frequency. Okay, they happen very often, but they're not very high, so it's low amplitude. Stage 2, okay, you're going to have these brief bursts of what they call sleep spindles right here, okay? So most of the time you're going to have your frequency is slowing down compared to stage 1, but then our amplitudes are going to get a little higher, but you have these sleep spindles where all of a sudden it's lots of activity in a very short period of time, and then it goes back to low frequency, okay? So that's stage 2. Stage 3 and stage 4 are more deep sleep. This is when we actually see delta waves. So delta waves are going to be very low frequency, so very slow brain waves, but very high amplitude. And so your waves are going very high, very low. And in the difference between stage 3 and stage 4 is that stage 3, you notice you have these pockets of delta waves. So here they kind of highlighted it for you that you have this pocket of a delta wave where you have low frequency and high amplitude, but then it goes to this period where it's more higher frequency, okay, and very low amplitude, and then you go back to a delta wave where it's very low frequency, high amplitude. And then in the stage 4, you have completely delta waves, and so everything is very low and slow frequency. You're in a deep sleep, but you have very high amplitude, so it keeps going very high. So that's stage 3 and 4. Okay, REM sleep. So REM sleep is going to be, it says you would expect a person to stay in stage 4 for 5 or 6 hours and then gradually move into a lighter sleep as morning approaches. But a person actually remains in stage 4 only a short period of time before moving back through the stages in reverse order. After the person passes through stage 2, the EEG tracings become actually very fast and irregular. And this actually looks a lot closer to a beta wave, like when you were awake and you were alert. Okay, so this is REM sleep. So while you're still sound asleep, okay, you have complete muscle relaxation except for the eyes. The eyes are kind of almost twitching. They're active. That's why it's called REM, rapid eye movement. Okay, so during REM, we have this very high frequency, very low amplitude brain waves. Okay, so summary. Okay, summary. So stage 1, notice we have very high frequency, low amplitude. Okay, stage 2, we have our frequency is slowing down, but then we have these sleep spindles where they're going to be very high amplitude, okay, very high frequency. And then stage 3, we're low and slow. So we're going to go nice low frequency, but high amplitude, but then we get to high frequency. So we have these periods and these pockets of delta waves, okay? Compared to stage 4, where you have all delta waves. Very low frequency, very high amplitude. And last, REM. REM is going to be where you're going to have that very high frequency, very low amplitude. Okay, so now that we went through all of that, now you have a quiz. Okay, so if you've already pulled it up, okay, you've pulled up the stages of sleep quiz, you should be on the first question. Okay, so the first question is asking about the first EEG reading. Okay, so based off from this, okay, what stage of sleep is this brain pattern, this EEG reading in? Stage 1, 2, 3, 4, or REM. So take a minute to select. Okay, you should have chosen stage 3. Oh no, it's not right, it's stage 4. I was tricking you. Notice that stage 4, it's going to be stage 4 because this is all delta waves, okay? So low and slow, so low frequency, high amplitude. This, okay, is your next one. So which stage is that? So pick one of the stages on your quiz. You should have picked stage 2. I picked the correct one this time. So this one, you see your sleep spindles in there. All right, this one is your next one. So which stage is that? 1, 2, 3, 4, or REM? So go ahead and pick one. You should have picked REM because this is going to be much closer to when you're actually awake, and this is going to be closer to our beta waves. All right, so now this is number 4. So go ahead and pick one for that. Stage 1, 2, 3, 4, or REM. All right, this one is stage 3. Okay, because this one you actually have pockets of higher frequency, a lower amplitude, compared to this one where you have very low frequency throughout. All right, this is your last one, last EEG reading. Yes, there is another question on your quiz. I'll get to it. So this one, stage 1, 2, 3, 4, or REM. This one you should have picked stage 1. Okay, so this one is going to be very high frequency, very low amplitude. All right, last question on your quiz. All right, so it says, now let's consider the relationship between sleep stages and mental activity. When people are awakened during slow wave sleep, in other words, stage 2, 3, or 4, about half the time they report that nothing was happening. In about the other 50 to 60% of the cases, they report that they were thinking about something. These thoughts or experiences are called sleep thoughts. They usually involve some issue or event that the person had been concerned about during the previous day. Sleep thoughts are not considered to be genuine dreams because they lack the vivid, action-packed quality of a dream. But when people are awakened during REM sleep, they almost always report that they had been experiencing an engaging, realistic, yet often bizarre sequence of events called a true dream. They were not merely thinking about something, they were actually doing something, and their actions were accompanied by vivid sensory experiences. They were seeing things and hearing things and touching things and moving about as if they were actually awake. So now consider this question, and this is your last question on your quiz. If people have vivid, realistic dreams during REM sleep, why don't they act out those dreams, perhaps injuring themselves or others? So think about that, and I want you to write your response on the last question on your Canvas quiz. All right, that's it for the video for this time. I hope you learned about brain waves for stages of sleep. Let me know if you have any questions in class. Bye.